without the video, but yes, I will start sharing the screen. Is that are you guys ready? Or did you have an expectation that it will be cybersecurity, not DevOps now at this point of time? Because to let you know that cybersecurity has, I have also given that message in the group that it has ended the previous week. Now today it is only DevOps, and we will end the session. So let us start with the. Yes, we are ready. Very good. Thank you. And Ishan, you have waited from the very beginning, from 7:30 p.m. in India time. That means almost like 1 hour and more than 1 hour now. So thank you for your patience. Let me start the session today from where we have left the previous Kubernetes session. So I will share the screen. Oh, let me first start the recording. The recording has started. So let me start to share the screen. Let me know if you can hear me properly and if there are no issues in seeing the screen. Are you being able to see the screen?
Yes, the screen is visible.
Yes, thank you. So I will switch over to this slide from where we need to start. We have done up to this. So up to this. Yeah. We will start from the cluster architecture of Kubernetes. For those who are joining fresh, the first day of DevOps, or maybe you have missed out on the Kubernetes previous session, for those, I will please ask them to, if they can check our YouTube site and get hold of the recording for the previous week to get a detail. I'm not going to repeat that because there is no point. So are you being able to see the screen? Right, I can assume that. And here you see you have two things, the control plane and the worker nodes. So basically think that this is the entire thing is a cluster. A cluster is a group of servers connected over a network. That is as simple as a definition of a cluster. So we say a cluster is a combination. In a Kubernetes, you have a combination of the control plane, which is the master node. So this is the master node, and these are the worker nodes. Worker nodes, you can say that this is the master, sorry. And this is the slave 1 and slave 2. What are these? These are nodes. This is another server. This is another server. This is another server. This is also a server, but this is the master server, the main server, the control plane. You see the control plane. Now the Kubernetes is a cluster of all this. In a Kubernetes cluster, the thumb rule is that for getting a good performance and all this, you can go up to one master and 40 slaves or nodes. Not basically, if you go beyond 40 nodes, then the performance and the distribution of the traffic and all those sort of service discovery and all those can go a bit. It can take a beating. So be sure that one master can only service 40 nodes maximum. So if there is a cluster of 100 nodes, you can go for 3 masters, second master and the third master. If in total you can divide it 30 and 30. So this third master can service 30 nodes in a cluster of 30 nodes, and second, but everything will be in one big cluster. And you can see how much it can go up. Okay. So in terms of that, we have to just understand the structure. One node versus 2 nodes. Here we are discussing one node, one master node versus 2 nodes or 2 slaves cluster. This is one cluster. Still we say cluster because why? Because all the networking tools, elements, everything will remain the same, whether you have one master and 40 nodes or one master and 2 nodes. 2 nodes. The networking elements, the amount of installation, and everything will remain the same. Installation of a cluster in Kubernetes is one of the talked about topic because it is not simple. Installation of a cluster of a Kubernetes K8s cluster is quite some work. It is not that easy, but it is not complicated as well. If you know the in and out of working of the things, the elements, that is what we are going to discuss today. So that when you do a hands-on of installing our Kubernetes cluster and making the cluster very robust, we need to understand the internal working. Okay. So the control plane, the master node, this is a server. Okay, the entire thing is a server. This entire thing is a server. So this server is having few components. We will install these components in the installation. What are these components? These are all Kubernetes components. I will say that this HCD is the brain of the master node or the brain of the cluster. And API server, this component of Kubernetes object or component, this is the heart. However good is your brain, however healthy your brain is, if your heart is not functioning, the entire system can collapse. So I will say both are important. It is not that even if the brain doesn't function, the system might not collapse, but the heart can become weak. And eventually the system will collapse. But anyway, it can still sustain a bit of time. But if the brain is good, but the heart has collapsed, you are dead. So I would say that API server, this component of the Kubernetes cluster or the master node, is the most important part. And it is, in fact, this is kubectl, kubectl. Kubectl is the Kubernetes CLI. Can anybody say what is CLI? What is the full form of CLI? Anyone? Are you being able to hear me? Nobody there?
Yes, sir.
Yeah. So, do you have any idea of the CLI? Any software like even AWS, when you talk about AWS cloud, this will also have a CLI component, and that is called the AWS CLI. What is the function of that? It is the command line interface. Why it is needed? Because if you do automation, if you wanted to do automation, you cannot go over a GUI interface. GUI interface can only give you manual control, manual activity, manual activity. But if you have the CLI, you can programmatically and therefore you can you can initiate automatic processes through CLI, through writing manifest files and executing them through the CLI. Okay, so these are the scripts, manifestation files, manifest files. These are scripts. This can be in Terraform, this can be in Ansible, this can be in GitLab, this can be in Docker, this can be in Kubernetes. Everywhere you write command line interface scripts, which can be executed through the commands of the command line interface. Is that fine? Any question? No question? So,
No
this,
question.
no question. Very good. So this CLI, this kubectl is the software. Is that a software which will interact with the Kubernetes. So this we will also install. But this is actually something like a call. This will make an API call. API call. This, this can be this you are running on a platform called Linux, because you have installed the entire cluster over Linux. So from the Linux prompt, you give the kubectl commands. That is the kubectl C, and then you give this is the command, and you can give the switches and whatever the commands. So this command is nothing but it will make an API call to the API server. Nothing goes anywhere else, not the nodes. Yeah, you will never work on the nodes. No kubectl commands or CLI commands work on this nodes, Kubernetes cluster nodes. No CLI commands. All commands will all come first to this place, nowhere else. This is the place, the heart. All the commands will be interpreted over here. Now, what is etcd? Etcd is a data store. It is a key value store. It is whatever the health and the information, the health metrics, because the entire cluster is a very complicated architecture, because you are deploying what? Can anybody tell me what you are deploying over this cluster, Kubernetes cluster? Why we are creating Kubernetes cluster? We have discussed that the previous session.
Automation.
Huh? Sorry?
For automation.
Yeah, the automation is fine, but what are you deploying over this cluster? This is called orchestration tool. Why it is needed? Basically, because you will be now deploying what onto this cluster? They are microservices, which are containerized, inside a container. So this microservice is an application which is as compiled or built as an image and put that inside a container, such that this becomes a dynamic object which can be just picked up and deployed over here, and they will start running. That is why you need an orchestration tool which can help them. It is like a platform. You are giving a platform to this microservices to run. And to run those microservices, you are getting into that big architecture. So our main focus is to enable this, and this is sort of a Docker image and a Docker container. Docker image, you have used the Docker technology to pack up or package. You package them into a what? Into an image. This is an application in form of a microservice. You package them as an image and put that image into a Docker container. You say you have containerized your application. These microservices can be hundreds in number, and they needs to be deployed over this. So it is like what you say. The various if the entire cluster is, we can say that this is the car of any model car. Okay, so the microservices are the various important functions of the car, like the brakes, the steering, the power window, the clutch, the automatic gear shift if there is it's an auto. All these are the various important functions which will be given a platform, like this is the model of the car, and these are the various parts that fit in. Okay, so whenever this brakes and steering and the accelerator and your clutch, everything goes, they are already created. But once they come inside the car, they start functioning and working with each other. The brake will talk to the clutch will talk to the accelerator, gear, and all the stuff. That will happen in a synchronized manner. And that platform is the Kubernetes. That's why it is called orchestration tool. Like there are so many orchestra players. Somebody is beating on the drums, somebody is playing the guitar, okay, somebody is playing the piano, and so many instruments. There somebody is playing on the violin. But there is one guy who is standing in between, in the middle of the entire hundreds of the musicians that they are playing the instruments, and somebody is standing in between or in the middle, and he is conducting the entire show. That person is called the maestro, or the conductor of that orchestra. Similarly, you can say that this control plane is the maestro who is conducting the entire show of hundreds and hundreds of microservices running in this cluster. But one more question. Where is this microservices getting deployed? Is it getting deployed over the master plane or on the nodes?
The nodes.
In the nodes. Not a single microservice or application will be running on this control plane. Remember that. But again, the question is, yes, I know, but who is controlling that? That nothing will come into this master node and going to the worker node. Either there are 2 nodes, there can be 5 nodes or 100 nodes. Who is controlling that those microservices or those pods? I will come to the term called pods. These are pods containing those microservice images in a container. So basically the pod is nothing but a container, but having an extra layer, abstraction layer over it. We will discuss why. But let us first discuss about the container, the architecture. Okay. So the last question that I asked was, who is controlling the distribution of those pods or the microservices over to the worker nodes? This is API server. See, everything coming inside the cluster, everything going outside the master node is all controlled by the API server. Yes, API server is like a manager. In a company, your manager is the person who is the one who does not work. This person is the most enviable person in the organization. This person does not do any work on its own. He will only delegate the job. The way and the expertise that he has to delegate the jobs here and there to the various employees, the best way he can do, the best manager he is, the better manager he is. How he controls the entire show it depends on how good he is as a manager. But he doesn't do anything everyone is helping the manager to accomplish the task. That is the function of a manager. So API server, I can say the heart of the entire cluster or the entire Kubernetes cluster, as well as this is the manager of the entire show. It is getting help. So the API call that the kubectl has created, or the command, the CLI command through the kubectl, you can use any other API, or you can go through the dashboard. There are few GUI dashboards which are coming up to interact with the cluster. But I will always, in our sessions, in our paid sessions, we always train our students learning the kubectl commands. Because the more and more you are GUI dependent, now what happens tomorrow? Your company decided that you will not have any access to this GUI because they have found that unnecessarily people are playing around with the features, and basically they can do a lot of harm. So they have taken out the GUI. So what you are left with, if you do not know, you are a Kubernetes guy, you have been appointed as Kubernetes guy, but you do not know much of kubectl, then it is very difficult for you to sustain your job. That's why in our course, we will always emphasize on kubectl, not in anything on a dashboard or a GUI. It is available in the market, but we always train them, because if you know the inner working and the commands, the CLI commands, you are a champion. You can easily get the Kubernetes administrator. It is called CAD certificate, KADM certificate for Kubernetes. And once you can get this, you are very much in demand in the market. And generally, it is a very tough prometric exam, but you can pass it only after you have at least 1 year of working experience in any organization. That is what we aim to give our students. So without certificates, they will get a job, and when they get a job, they at least do the job for 1 year, and then they go for the certification. It will help a lot. Because without practical knowledge of how things happen, however good you study in the theory, it will not going to help. You may not get this certificate. It is one of the toughest exams. It is a 6-hour exam. Okay, so no worries. We are not going to sit for that exam right away. We are learning the internal architecture. So this kubectl command will be interpreted over the API server. API server will take the help of, this one, HCD. HCD is a key value store. Whatever the help parameters of the entire cluster will be stored over here. These are the database. So I have a replica. This is replica 1 and replica 2. They are having the same data, but they are having 2. At least if one dies, this is again a pod. What is this? API server. Can I say this is also a pod? Yes. I mean, it's an image. It's an application running inside a container, and the container is inside the pod, having an extra layer, abstraction layer. Can I say this scheduler is also a pod, and this is also a pod? So these are the components which are also a microservice or pods. Why microservice? Microservice because they can run independently without, they are called loosely coupled. Why? Because they do not depend on the other components. They can run on their own. If this pod dies, that does not take away that does not force this API server to die, or the scheduler to die, or the controller manager to die. The application is still running. The control plane is still running. Maybe this pod has died. But since it is a replica, immediately Kubernetes will, suppose this has gone off, it has died, immediately this will be replaced by another pod with the same data replicated. So this is a fantastic architecture and a structure. You will always get this cluster available for almost 99 point. There are 11 nines. %. Can you believe? Yeah, I'm not saying 100%. Anything can go wrong because it's after all a system. But can you think 99.11 %? Because of this exclusive architecture. Exquisite, sorry. So the API server, everything is a pod, and they are running within this master node. API server is taking the help of the information that is stored over here in the HCD, and then it will take appropriate action, and it will then ask the scheduler to do something about it. Because as I told, it's a manager. It doesn't do anything of its own. It will call the scheduler. Scheduler will take the help of controller manager. Controller manager is a very important part. Anything going out from this master node is through the controller manager. Anything coming inside the master node is through the controller manager. Yes, immediately it will pass this information. That's why can you see that there is a link. Immediately it will pass that information to the API server to process that information. An API server will immediately consult HCD for the data to check whether the thing is there. whether there is some anomaly, some discrepancy, some information which is missing. And if there is, it will ask the scheduler to rectify the work. I will tell you what. Scheduler will call the controller manager. Controller manager, now let's say I'm coming to the node. In the node, this is the manager. Like the API server, the manager of the pods is the kubelet. And this is the container. Container means these are individual containers. These are individual microservices which you have deployed with the deployment manifest. That is also a Kubernetes object. You create it over here. So deployment is one of the manifest file. Deployment, you will create a script of Kubernetes deployment script, which will deploy these pods and replicate. So this is, let's say, a Java application, microservice Java application. This is having 3 replica. So when you declare that as a manifest, what is manifest? Can anybody tell me? What is manifest file? What is manifest? What do you understand when I say manifest?
Desired state.
The?
Like a desired state.
Yes. Manifest means what you desire, what you want. What you want, you write that in a script called deployment script, which is a Kubernetes object. You have to execute that through the kubectl. So the kubectl will execute this deployment manifest file to create these pods. So they are all linked. So this, when executed and created, will create these pods, or just say containers. Along with that container, inside the container is an image, or let's say a Java application. So this has been replicated 3. A replica of 3 is desired in the manifest file of deployment. So it is not 1. It is 1, 2, 3. So 1, 2, 3. They are the same application. They are the same image, but in 3 containers, which are replica. The meaning of a replica means that if something, let's say this has gone down, a pod can anytime go down. That's why pods or containers are very, very ephemeral. Ephemeral is a term to signify it is temporary. It is temporary. Anytime it can go down. But then you would say, then Debashish, this becomes very, very unstable. You say that anytime this can go off, the application will go off, can go off. It is not anytime, it may. But don't worry, because you have desired 3 replica of the deployment of this pods. This will be immediately replaced by another pod with the same application. This is the mechanism. Yeah.
Can I ask a small question?
Yeah.
I'm just thinking in my mind, as you're saying, what in terms of the volatility of the setup. So why does it really, when it speaks about, let's say we have a DevOps team, and then you also have the issue where now probably, let's say, can it ever happen that maybe probably the entire cluster goes down? And then what does it really speak about in terms of let's say you've deployed this on your AWS server? So what is it, when it comes to that, what does it really speak to in terms of the costs? Because we'd have to really start afresh and redeploy or restart the service, whichever way, what does it really speak about in terms of the costs? I'm just particularly concerned about that.
Yes. So very good question. Actually, that is where the services of the cloud pitches in. You can have a SaaS service, as software as a service from AWS, from Azure, from Azure. You think that you have set it up yourself, okay? You have installed every bit of thing, and your cluster is running fine. And you have monitoring tools. See, it is like a self-healing. It is
Yes,
like a
yes,
human body.
I was actually asking that in terms of, do you, when you're using, let's say you're using maybe whichever you choose, whether it's Prometheus, Kafka, or Grafana, do you monitor from an external or an internal setup kind of situation?
Yeah, I'm coming to that. But before that, what I'm saying is Kubernetes itself is like a human body. Your body heals itself. There is the immune system, and there is a self-healing mechanism within the body. Think Kubernetes like a human body. Okay, so if something goes wrong, it also knows how to recover it. I'm not talking about the pod. The pod will recover it automatically because there is the deployment, the manifest file, and you have desired three. So one, I will tell you how it is recovered. Okay. So always you will get three pods of the same application, of the same image. But now, even though you have installed yourself, and there is a Kubernetes itself, by the software itself, is a very self-healing, still there is a chance, and you have a very robust monitoring system like with Prometheus or with Nagios or with Splunk. You can immediately get something which is you have implemented those, and also there are microservices which are available which can monitor itself, the entire applications which are microservices which are running, whether they are healthy or not. And there is lots of RAID mechanism, redundancy, because this is after all a hardware architecture. Okay, the servers are itself very robust and resilient. They can withstand a lot of pressure, lot of load. Anyway, and there is also a redundancy built in within the architecture. So if something goes wrong, see, the master node will be also a replica will be there, a replication server will be there of the master node. So if there is a 1 versus 30 nodes, so this master can go anytime down. So there is a replica, a standby server, a redundancy. So this standby server will pick up if it goes wrong. So even after you have done all this setup, hardware setup where there is a RAID mechanism implemented, it is itself a self-healing, and the mechanism is so vast, and but still you think that you have not done enough. So in that case, you have the last resort. You can go and purchase the EKS or the AKS.
Yeah, so it means more costs. That's what I
Yes,
wanted to find.
yes. It is
Okay.
Elastic Kubernetes. Yes, of course, you have to pay for your Kubernetes service. And this is from AWS. This is from AWS. In our course, we also have given the documents so that you can install this yourself using KubeADM, which is again coming from Kubernetes. So with this tool, you can install the entire Kubernetes architecture. Otherwise, there is also in the document, we have also given you how you can establish the EKS. But the E case, I do not demonstrate directly on the in our sessions, in our class, in our paid job ready training, because E case for our students who have not yet got a job, it can cost. But yes, once you get a job and your company allows you to implement E case or A case is Azure Kubernetes service from Microsoft. Okay, then whatever little doubt, that 10% doubt that you had of your security and redundancy, everything goes, because now it is the headache of AWS to maintain the clusters. They have lots of expertise in doing that. That's why it will cost you. It will cost a lot. Yes, but you will get the benefits. Did I answer your question?
Yeah, yes, you've answered it, sir. Thank you.
Okay. Now I will just remove this part. I am using the same slide to explain you lots of slides which is coming. I will not go through them in details because we have already discussed them. Okay. So the question is, what happens if there is a pod which is down? What is the internal way? Okay. Now, so my thing is, oh sorry, this pod is down. So what will happen? Let us understand what happens. So who is the manager of this entire pod and of this worker node? Kubelet is the manager. Kubelet is one of the Kubernetes components, but this will be installed over. Yeah, see, everything will be installed over here on the main cluster, but then Kubelet is particularly a component which API server knows that it is a component meant for the nodes, managing the nodes. You can say it's a node manager. At the same time, it is the manager of all the pods available in that node. Okay, and kubeproxy is the network component on the node. Network component of Kubernetes on the nodes. There is also a kubeproxy over here. Now again, I will tell you, these are all pods. This is also a pod. Kubelet is also a pod. Everything is a pod. Kubeproxy over here is also a pod. So there are two kubeproxies, one on the master node and one on each of the worker node. Why? Because kubeproxy will take care of the networking between the servers and the nodes. Servers means the master node and the worker nodes. So what happens? Let's say this pod has gone wrong. This is down. This is down. But what you desired 3. So what should happen? Instead of 2, I should always have 3. How does it happen? So Kubelet will get the first-hand information that this is down. Kubelet will understand, because Kubelet gives the heartbeat. With each of these pods, Kubelet exchanges heartbeats to understand how is the health of that pod. With that mechanism, it will understand that this pod is down because I am not getting any response from this pod. So this pod is down. So who gets the first-hand information of the health? It is the Kubelet. Kubelet will pass on that information to whom? to kube proxy to say that please let master node know that this one is down. This one is down. So kube proxy, which is also a pod, will process that information and it will put that into the to whom? Who will get this information first? The control manager, right? Controller manager. It is from the kube proxy. From the kube proxy, this information is coming to the controller manager. Because as I said, actually the controller manager is an interface between the worker nodes and the master node. Everything coming in or going out will be from this. So kube proxy will let this kube proxy will take that information from the node into the controller manager. Controller manager will immediately send it to the API server. API server will immediately consult the HCD, the database. What does HCD say? That this particular pod, by some pod label, there is, with the deployment, it knows that there is supposed to be three replica. With that information, and that API server knows that kubelet has given that information that right now there are two only. It needs to be promoted to three because I get that information from the HCD that there should be three. So what it does, it gives that information over to your scheduler, because this is the guy. This guy will manage or recreate the pod. How? It will pass on that information, or rather it will authorize the controller manager to call what the controller manager is actually a manager within which it will have several managers, and one of the manager is the replication controller. This component, which is a slave component of controller manager, will then take that information and it will pass on to the kube proxy, and the proxy will then, what will it do? It will give that information to kubelet, and kubelet ultimately, with the help of the scheduler, kubelet will replace this pod with a healthy pod. Is the entire flow more or less clear? Any doubt? So what did you get? You got the three that you desired. And this, you are saying that to explain it, I took almost 10 minutes. But it is a fraction of a second that you will, even if you try to watch it with kubectl, what is happening, how it is this getting replaced, you will may or may not find it is so fast. Immediately it will be replaced. Even before your command has been executed. You will not be able to watch it most of the time. Okay? Any question? And another thing is, the end users who are interacting with the nodes. Why? Because this thing is actually the users are only meant to access the application. They do not know what to interact, how things are happening inside. They will just interact with this, but can you see these are dashed lines? These are dashed lines. That means the end user query will also come to the API server. It is from the left-hand side or from the right-hand side. Either it is coming from the kubectl, it will hit the API server, or it is coming from the end users, it will also go and hit the API server. API server will then do all those activities. It will call a service. Deployment is backed up by service. Okay? Any question? Because without a service, you cannot discover your particular pod that you need. Here, for the sake of clarity, for the sake of simplicity, it is only 3 pods, but here there can be thousands of pods. So you wanted to reach one application, one particular pod. Is it possible without the help of the service? Service will navigate through all this complicated networking and will then reach over here that you wanted. Each deployment is attached with a service. So this application, this Java application, which is out of this deployment, you have deployed these Java microservices over as pods through this deployment will be attached with a service. So any deployment, if there are 100 deployments, deployment manifest files, how many services you will have attached? You will have exactly 100 services, separate services. Each deployment will give you the label of the pods. The pods will be labeled. Let's say this is Nginx application. So Nginx label. Another deployment was, so there will be a service attached to this. There will be a service. There will be a service attached to this. And you can name whatever the service. Every object will be having a name. So Nginx service. Here you will have another deployment. Let's say a Java deployed Java application. And you will similarly have a service attached. So Java service. Now there can be hundreds and thousands of such pods and services attached. So if a user using the browser of your laptop, is trying to get an application called Java, then it will access the Java service to help reach the endpoint. This is the endpoint. And that is the most critical part, that is called service. What is that? Service discovery. It is like discovering the world. Without the help of service discovery, you will not be able to reach your destined endpoint. More or less, is this clear? With one slide, I have covered up so many topics. I will remove this. And we will go to the next slide. It is exactly I have already done. Yes, one part is the load balancer. The load balancer, so the end user will be requesting for a particular service, okay? Service, like the end user is looking for a pod to access a pod, an application. And there can be millions of end users with millions of requests, all coming and hitting the load balancer. All coming and hitting the load balancer. So this load balancer can be from AWS, called Elastic Load Balancer, or from Azure Load Balancer, or whatever. But this is the costly part. This will cost you. So as a Kubernetes guy, you may be wondering, if I'm getting everything from Azure or AWS, then what's my demand? Why will a company employ me? You will be employed because, first of all, you can establish the entire network yourself. as well as you can avoid using an AWS load balancer or Azure load balancer. You can implement an ingress controller. This is another thing. It's a very good topic of. So this will act as a load balancer, but it will be entirely configured and done by you with another object called ingress. Ingress, which is nothing but a set of rules, which the ingress controller, which is a load balancer, will consult this ingress rules, which is an object set of rules, and that rule will actually define the services and the path which leads to that service. So it becomes much more easier for you to look for a particular service, like for this pod, because you are hitting the ingress controller hitting the ingress rule, and if your query, your URL has the endpoint, and that endpoint matches with that rule, you are there. You have reached this pod. Or this pod. Are you getting me? So that's why people will hire you, the organizations will hire you, because you know how to implement this, instead of, because you can save a lot of money for the company. First of all, you are not using EKS or AKS, which is costly. You have done your implementation yourself, entire thing, you know how to do it. And also you have, instead of a load balancer, you have created your own ingress controller and ingress rules. Is that clear? Any question? See, I do not have any scope of going into very much details of it. I will just give you an overview so that you can appreciate the power of Kubernetes, and then you try to learn it. I'm not saying you have to learn it through us. You can learn it through YouTube. You can learn it through documents. There are hundreds of documents available. Okay, or you can go to any very big institutions, not in small institutions like us, a small company like Kalkey. You may not come to us. You will pay a lot more money, and maybe you are learning a little less than what we teach. Anyway, just I was kidding. So we will check out this. Move on to the next slide. So as we have already described, about only one thing I have not described is the cloud controller, Kube controller manager. No, it not be Kube cloud controller manager. This is controller manager. This is cloud controller manager. This is an additional plugin or a component, Kubernetes component, that you can install if you have gone for EKS service or AKS service of cloud. You have a connector with this controller manager. So all your EKS related commands and everything will come through this and managed through the cloud controller manager. In that case, Kube controller manager will be secondary. First interaction will be happening over there. You see in the middle is the API server. This is the HCD. This is the Kube controller manager, and the scheduler. So all the four important components are there. This is additional if you go for EKS or AKS implementation. When you come to the node, this is the node. This is the master. In the node, you have the kubelet, you have the kube proxy. For each node, you have this kubelet and the kube proxy. And what is the common part in both of them? In both the master and the worker nodes, what is the common part? Common part means what is the common component? Common installation that you need to do, without which your Kubernetes will not function.
API.
API server.
Hmm.
API server is only for the master node.
Okay.
Okay. You do not have any API server over the worker node because that is not needed. This is the control plane. Think of one thing. You are dealing with pods. You are dealing with everything is a pod. This is a pod. This is a pod. This is a pod. This is a pod. Even the kube proxy is a pod. Kubelet is of course a pod. So what is that you are missing? You cannot survive without installing that in both the master and all the nodes.
Like an IP.
What?
Service?
Which one? Service is what you will be implementing a service and the deployment manifest file that you are doing it as a Kubernetes object. This is not a part of installation. You will do it afterwards, after your cluster has been created. Deployment, service, secret, config map. These are objects but these are manifest files as well. Config maps for security reason. You will learn cybersecurity. This secret, config maps, these are part of cybersecurity, DevSecOps. Okay, you will need to learn it. Anyway, so these are, you will implement it, but these are not part of the installation. These are the Kubernetes objects that you will create later on. Okay, what is the installation part? Huh? Remember, I have not mentioned Docker. Isn't it? So I understand that you understand that without the installation of Docker in this, as well as this, everywhere you need to install Docker. If you have 100 nodes, 100 worker nodes, you have to install Docker 100 times on each of the node, and one, of course, on the master. And there is one more component. Apart from all these components, there is one more but that is a third-party tool called the pod networking. You have to establish a pod network, but because all these pods will need to talk to each other over and across the nodes. You see, these are very different nodes. This is one node as well, master node, but they have to communicate with all the pods. So the API server will need to communicate with the kubelet pod. How will that happen? That will happen based on these are the nodes, master node, and these are the three this thing. So this is the pod network that you have to establish, you have to install. And that is done. There are two famous pod networking tool that you need to install. One is called Calico, and the other one is called ViewNet. Both are equally good. Both are famous. Both are popular. Generally, in my sessions, I install through the pod network through the ViewNet. But Calico is also very good. So understand that after you have to install Docker as well as the ViewNet or Calico as a pod network. So you have done the complete thing on you have done it from the scratch. That's why you will be called and given a job. So as I said, you need Docker. You need Docker. You need Docker. You need Docker. So in the master node and all the worker nodes, you need Docker. Don't underestimate Docker. Docker is without Docker. Docker is the backbone. Okay, And this, of course, HCD, API server, scheduler, controller manager, and here you have kubelet and kubeproxy. Okay, this on the sleeve. Any question? So same thing. Now, this generally the master node is always on Linux. You cannot have a master node on. It is not cannot. You can, but at least you will have a virtual machine, either Ubuntu or thing virtual, like on the virtual box. Let's say you are using Windows, you can have your Kubernetes master, but on the VM, not directly on the Windows. You will have the Ubuntu or Red Hat or whatever as a VM. But generally, you will do this on a Linux server, EC2 instance, Linux, or Azure server, whatever, wherever you are. So that is a master node. And the worker nodes, your node can be Windows, your node can be Linux, your node can be on Mac. Node does not matter. Yes, you have to put them into the same cluster, both the master node and all the worker nodes. Worker node, worker node, worker node, all inside the cluster and the master node. You see, kubeproxy is what it will is like the networking. It gives you the network layer of the cluster. You have the container runtime, which is mostly Docker, but it can be Mesos or Rocket. But they are so insignificant that people always talk about Docker. And you have kubelet on the node. Any doubts, any question, please let me know. Now, I have described about what is HCD. We have discussed about things, isn't it? We have discussed that it's a key value store where all the health metrics, what is happening, all the statistics of the of even the secrets, the passwords, the tokens, every information that is floating around in the cluster will be available in the HCD. It's a very, very important part. As I told you, it is the brain. It can register all the data. Then there is the API server. As I told you, that is the heart. Without API server, you cannot be communicating or processing your request over onto the Kubernetes cluster. Similarly, there is the scheduler. The scheduler will schedule it will schedule on the nodes. It will schedule the pods. That is why it is called scheduler. It will take care of the resource need of each and every pod. So during the deployment, you have specified the resource specifications, that how much CPU a particular pod will take, how much memory a pod will take, how much storage the pod will be creating. All this can be specified in the deployment manifest file. And with those specifications, the scheduler will schedule. In the deployment, you have said that I want 3 pods and replicas of that same pod. I want 3 replicas. But who will implement those replicas is the scheduler. And the scheduler will take the help of whom? For replication, it will take the help of controller manager. And controller manager in turn will take the help of replication. What? Replication controller. That is the way. So, but ultimately, this is the guy who has scheduled the number of pods, if there were, and how many CPUs and RAM that particular pod will need. All those things will be scheduled accordingly as per the deployment. Similarly, there is a controller manager, and can you see that the controller manager is again in turn helped by whom? The node controller, the replication controller, the endpoints controller, the service accounts, and the token controller. These service accounts are very, very important for security purposes. You will ask why Kubernetes is so secured. The transactions over the Kubernetes is very, very secured because you have the service accounts, and without those service accounts and the token controllers, you will not be able to access the cluster. Service accounts follows the rule-based account control, RBAC. This term is very, very frequent. It is very frequently used in the DevOps jargon. RBAC. Did you implement RBAC? Yes, sir, I have. It is through what? I have created service account. Oh, great. Did you install rule-based or role-based account control? Yes. Through what? By service accounts. But I have created service accounts. And who is the controller of the service accounts? It is the controller manager, right? So you say this is my main manager, the project manager, and the project manager will have functional manager, test managers, team leads, all under the PM. The operations, the service manager. Okay. But all these are similarly in your controller manager, it is having sub managers called node controller, replication controller. Through the replication controller, it is creating those replicas. It is helping the scheduler to schedule the replicas correctly. The node controllers, it will control the node. Suppose a node is down, so immediately the scheduler will schedule another node, exactly a replica of that node, with the entire architecture done. So these are redundant systems. RAID architecture is also implemented. So this is the controller manager. The node controller controls the nodes. Replication controller, replication of the pods. Endpoint controller exposes the endpoint API services. Service accounts, which authorizes users to access the Kubernetes cluster. This is very important. Service accounts for security authorization. Now, similarly, you will learn that the kubelet is there, which is a manager for the node and the pods, and the kube proxy. Kube proxy is sort of a networking component of the cluster. So what happens, and of course there is a container runtime. The Docker is the container. You have to have that container runtime, without which the Kubernetes will not function, will not be up. What happens if the master node goes down and the API server components crashes? It is a very common question. Will the applications running within the pod stop running? The answer is no. As the worker nodes and the pods continue to run, though no changes to the pod or the node configuration can take place unless master node is made up and running. If you need to make any changes, it cannot happen because your master server is down or API component has crashed. So we have the pod. Pod is the smallest unit of Kubernetes. It is an abstraction over the container. So as I told you, very important to understand that you have a container. This is a container. Container is like you have seen a ship carrying the container, and there is something which it is carrying, and that thing is nothing but the image. There is one image. This is the image. Okay, and you apply this layer is an abstraction layer. What do you mean by abstraction layer? That is, it is, this is something coming from the object-oriented programming. Oops. Abstraction is an oops concept. It is not physical. It's an abstraction. So because there is few, this will not do. What I will do is use this. Okay. Or we can use the red one. Yeah. So the abstraction, what it does is it will be sort of, an oops concept of creating a layer, and that means some extra feature which will be added on top of the other object. These are all objects. Like the container is one object. The image is one object. So I say the container has embedded another object called image. And can I say, so this is a concept in, let me have some water, just excuse me. So what I'm saying is, can anybody tell me what is the oops concept of embedding something, an object within an object? If you have any concept of oops, like Java, like C++, like C hash. These are all object-oriented programming languages. Okay. So this concept of embedding an object within another object is called, anyone? Encapsulation. So can I say that a pod encapsulates what? Containers. Can I say that? Yes. So because pod creates an abstraction layer over the container. Why? Why? Because see, this is the pod, the outer is, this is the pod, and this inside is the container. So why there is a need for pod? Because a pod, usually one application per pod, that is okay, that is a thumb rule. Each pod will get its own, because I need to, you see, it will be very difficult for one container to talk to another container or to get connected over the network as a container, because the container does not have an IP address. Container has a port, of course, a service port. But it is very difficult for a service port to talk to another container through a service port. It is almost like very difficult. So you have a Docker Swarm architecture where it was container to container communication. But this is not very flexible. So therefore, it has given rise to Kubernetes. Kubernetes is much more flexible, much more robust, and this communication happens because now you are not restricted to container. You are having a pod. And this pod will have an IP address. So to communicate between the pods through the IP address becomes very, very simple. Like any device, any device, a laptop is communicating with a EC2 instance or a cloud server. Why? How? Through IP address, through SSH connectivity. Similarly, a pod will communicate with the other pod through IP address. Okay, that is because you have deployed a pod over a container. This is happening through the deployment manifest file. You are creating pods through the deployment manifest file. And now the problem is, if you communicate over IP, if the communication is over IP, what happens is, if this pod dies, what will happen? This pod will be replaced. Yes, that's absolutely possible because you have replicas. Replica is another object. Replica set is another object that is created through deployment. Okay, and you say, I want 3 replicas of this pod. Yeah, but one has died. So that means this IP address will now, what the new pod that will be created will have a different IP address. Do you understand? The IP address will be different. It will not be the same IP address. The IP address will be randomly allocated. So each time, see, this was communicating, one was communicating with 2. Now, after this 2 has died, one will need to communicate with, let's say, 7. So you have to adjust. This will not work because it is died. Again, you have to adjust your communication with this pod through 7. So IP address has changed. So you have to change the addressing mechanism dynamically, because you cannot manually do all these things, because every now and then, how will you monitor? How will you change? So this is one of the difficulties of having IP address. So what the deployment does is, we have another concept called service. So a service will replace the IP address. So what we say, we will attach a service. See, the pod IP address will always be there. Any pod will have an IP address, but we are not communicating through IP address. Now we are communicating with the service because we have created another object called service. And there is a IP address also attached to this IP address. See, service to the objects will communicate with each other through IP address. Always the communication will happen through IP address. IP address, there is no other way of communicating between the objects over a network, is through IP address. But it will communicate between this service and this service to get attached to this service, to this pod. But if this pod dies, will the service die? You tell me, because now it is this is an object, separate object. object. Yes, these two objects are linked to each other. They are attached to each other. But if this object dies, does that mean that this object will also die? No, it is still live. So if this pod is replaced, it will again be attached with the same service. So now that is a big advantage. I do not need to manipulate this connection. No need. Because the same IP address will be continuing to communicate with each other. Is that clear concept?
Yeah. I have a question, sir. So how does the pod attach to the service?
How does the service attach to the pod? Through, very good question, fantastic question. It is through a manifest file called service. Remember, the pods are all labeled. So let's say you have a replica of 3 pods, 3 replicas. So these are Java application, Java images, Java, Java, Java. Same application, but in different containers and pods. So now these pods can communicate with each other because they are attached. This was created by whom? By the deployment manifest. Now they are labeled. So they got a label. So do you think they will be different labels? No. The deployment will create 3 replicas with the same label. Let's say I have given a label called Java app. You are giving it. You are giving the manifest deploy. You are creating. So you are giving a label. Okay, a label. So this label with the same with the 3 pods, Java app. Now you create a service. That is a manifest. You will create an object called service. And now in the service manifest, you say that I want the service to be attached to this particular label. So once you give that, and no other set of replicas will not have the same label. If you do that, it will not allow. So no duplicates. This label has to be unique. So this service will attach to this label. That means this pods, this group of pods, or this replica set of pods. Another 3 you have for Python. To the deployment, okay, manifest. So what will you do? You will create a service. You have given a label called Py app. All the 3 will be having the same label, Py app. Now you will create a service manifest file and you will specify in that you want to attach to what? Java app or Py app. If you say Java app, it is wrong because then you are creating a 2 service to the same. This will not work. So you will say that you want to attach, or this service means you will discover these pods through this service. So you will say that you want to attach to Py app. Are you getting me now? So this is how for each deployment, one deployment manifest, you will be having an attached service, one service. That service is important because the users will connect. So the users will connect to this service. This service will take you to this pod. How you connect to this service is another chapter through the ingress controller. Which has the rules, that rule will take you to that. So this will specify through the URL, you will specify that endpoint where you want to, which application do you want to access. So that endpoint will actually be a set of rules will be checked. whether this endpoint matches one of the rules. And if it matches, then it will pick up that service which matches that rule, and that service will take you to that pod. This is the load balancer, ingress controller, or the load balancer. Am I clear? If not fully, but at least some idea you are getting. How in this world of, in this mesh of microservices, how do you reach one particular service or microservice? It is through the service. Service will take you to that application. This is a pod. This is a pod. Service will take you to the pod. It knows how to communicate and reach that pod. So this is called service what? Discovery. You have to discover your path to go to reach the destination, the endpoint. Clear? If not all, at least something. So a replica set is like you have done it through the deployment. Replica set is an old concept, but you could have created replica set objects. Right now, you do not need to do. Replica set is replaced by a higher level concept called deployment. Are you seeing this? Replica set is replaced by a higher level concept called deployment. You do not need to create replica set. Earlier in prior to version, see, you started from Kubernetes version 1.1, and now you have traveled a long path. Now you are currently using Kubernetes version 1.30. So up to version 1.19, there are two worlds. You say prior to 1.19 and post 1.19. Anything post 1.19 is, the latest. So this is the replica set world, where you created pods through replica set, and now you create after 1.19 and up to 130, it is deployment. It is much more advanced, and because of this deployment and with its flexibilities, you can do a Kubernetes blue, green deployment, canary deployment, which is a very fantastic way without having no downtime, because it is very difficult for any of our customers to convince that I need a 1 hour or 3 hours or 6 hours downtime. As a project manager, I used to do a lot of negotiation with our customers because downtime, downtime is a loss of business. Though we used to do in the very deep in the night from 12 AM to 6 AM, 6 hours. We need a downtime and we will deploy our new features or new product into the production. But nowadays, you cannot even think of, can you think that Amazon.com or Microsoft.com has gone down even for 1 hour? 1 hour is too big a time. Even if there is a 5-minute downtime of these running servers or Amazon, there is a huge loss. Huge loss. Can you see that eBay, that consumer site for e-shopping, eBay, can you think that it is down for 10 minutes? How much business loss it is? So downtime is a curse. Nobody will agree nowadays. Say, 10, 15 years back, the customers did not have any option. But now if you go and ask your customers, say, sir, I need a downtime of 6 hours, and I will deploy my product, he will just start screaming at you. You are a worthless project manager. You please go out of my room. I cannot even give 1 minute downtime to you. So you deploy it without disturbing the current running system. And that is the beauty of it. And that is possible because of the deployment manifest files. You can do a rollback and roll out.
Hello, sir.
Yes, yes.
Yeah, in fact, you just mentioned where I'm actually coming to now. So in an interview, and they ask you, what do you understand by blue-green deployment, or explain a blue-green deployment?
Yes.
In what situation or whatever, or in what, infrastructural service or tools?
Whenever they will ask such questions, which are subjective questions, you
Yeah.
will start, because it is the ball is in your court. Again, I'm saying, because you know the concept, you start from such a point that your answer will be too long. You keep on saying this and that and this and that. Actually, you are doing everything. You are to try to explaining the blue green deployment. You can show your skills that you know a lot on Kubernetes. That is how you will address any question. You will have to articulate in such a way that it is your forte, your strength is you have a knowledge of internal working of Kubernetes, and then you start. You first half you explain that you have a knowledge on Kubernetes, though they have asked you blue green deployment. Actually, innerly, I mean, behind the scene, they wanted to understand whether you know Kubernetes or not. Otherwise, they had no purpose in asking suddenly out of the blue to let you ask a question like, what is a blue green deployment or a canary deployment? Can you explain that? You are not an operations guy. You are a DevOps guy. Okay. They wanted to understand whether you are coming from the very source. If you say, sir, deployment is blue green deployment is like a production system is running, I do not want to disturb it. There is a blue part which I will try to convert it to green. Okay, so I will gradually take out the which is running, but phase by phase. I will roll out my new features, new product gradually. I will test each and every then and there in the production itself. And once the testing is done, I will then replace that module with the higher version module or the new module. So it will be roll out. It is rolling updates. The main purpose of blue green deployment is called the rolling updates. So you are updating, but the term is called rolling updates. And when you say you are deploying something, it is called rollout. So you are rolling out your blue part and gradually rolling update the green part. The green is the current one which is running in production. This is all happening in the production box. So you are deploying on the production box, but at the same time you are testing and everything on the production, and you are gradually replacing the one which is running with the one which is getting deployed. So your users who are connected to your system does not understand that a version has been upgraded. Like in Amazon shopping site, Amazon.com or Amazon.in for India, Amazon.uk for UK, Amazon.us for US. So whatever it is, so whenever this is a e-commerce site, and you will not understand whether Amazon is upgrading their products catalog or whatever, but it is not impacting the customers or the users. They will not understand what is happening in the background. But Amazon is doing some deployments. It is some rolling updates are going on. Blue-green deployment. Yes, you can go into much more details. In our session, I generally give a handout for blue-green deployment, one article. So they can understand a bit more by reading that article. Or you can go to internet and look into in more details about how things happen, what is the diagrams. You will find it very fascinating. And those type of deployments are easily available or easily done through your Kubernetes cluster when you deploy something over a Kubernetes cluster. So Kubernetes has become a very, very important consideration for the industry. So what you deploy the application, isn't it? You deploy your new application over the production box. And these applications are in form of microservices. And the microservices best platform is Kubernetes, because these are containerized applications. And in Kubernetes, you can do the rolling updates. So they are all win-win situation for knowing Kubernetes and learning Kubernetes. Did I more or less answer your question? So basically, they wanted to understand
Yes,
whether
sir.
you. Hello?
Yes, sir, you did.
Okay, thank you. So always try to not answer the question directly. If you know much more on that, you try to kill the time. That is the technique. You need sometimes you get a very favorable question. You know a lot about that. So you try to not stop at that. You try to cover up most of the time in answering that question. And in that, but don't try to say something which is not relevant. It is relevant. Blue-green deployment means they are trying to understand whether you have skills or you have some experience over Kubernetes.
Mhm.
So try to explain that in larger details. So a deployment, can you see this is a rolling update? You see the rolling update. Pause. You can pause the updates as well. See, these are the advantages. You have the update strategies like the rolling updates, paused updates, and rollback. And sometimes your entire thing can go wrong. The testing has gone wrong. So you took a decision that no, I want to roll back. I wanted to upgrade, I want to roll out, say, version. This was running version was 1.0. I want to roll out version 2.0. But in between my testing, something has gone wrong. Anything can go wrong somewhere. So you were doing the rolling updates, but something has happened. So you decided, see, something you have already updated of this, some modules you have already updated, but then you faced and encountered an error. It will be very difficult to restore it back to 1.0, but because of this deployment manifest, you can do a rollback quite simply. It will be simply, whatever it has been updated will be simply reverted back to the old state. Otherwise, you will simply gradually, one after the other, layers of replacement will be done, one after the other. There's a very nice article. If I would like to post that in our group, internship, Kalkey internship, I will post it tomorrow. The blue-green deployment article. Okay, you can have a good read on that.
Okay, sir.
Yeah, it's a very. I will arrange an article on blue-green deployment as well as the canary deployment. Both are very, very important terms nowadays. So you deploy the application in form of pod, okay, through deployment. So deployment, you deploy the pod, pod contains the container, and container contains the application. That is the hierarchy. So you have a deployment, you have done a replica of the same pod or same application over 3 pods, let's say. Similarly, your service, you hit the, as a user, you hit the service, and the service will take you to the relevant pod because you have done the pod leveling. Can you see? Sorry. You can do the pod labeling during the deployment of the pod. So during the deployment manifest, you have labeled the pods, and then your service is hitting that label. So that means this service will only land up or end up over here, either here or here. See, one request coming. This is one request, one service request hitting the service. How many pods will it hit? The answer is only one pod, either this or this or this. And but so service is also a sort of a internal load balancer. It has a service has an inbuilt load balancing algorithm. It understands which one is the healthy pod. It will only divert that request to that healthy pod. Healthy pod means not always that the pod is sick or going to die. No, it is maybe the pod has almost occupied all the resources that was assigned to it. Let's say it was assigned one CPU, 50%, or say 70% of that CPU is the threshold. Threshold means whenever it reaches the CPU usage of that one CPU on 70%, it will set an alarm that it is too busy or it is not in a, it will set, it will taint itself. Tainting is one of the very important functionality of Kubernetes. It will taint itself. Taint means it will say that please do not send any further request to me because I'm too busy. I have occupied almost 70% of the CPU and almost 80% of the memory allocated to me, allocated to this pod. So I'm too busy. Whereas this pod is only using 30% of the CPU and only 20% of the memory. So this is relatively very, very good condition in respect to this. This is not ill or sick. It is only that it is too busy. So service will understand that and divert that request to use this pod, access this pod. Are you getting me? There are two types of service: external service, which is the node port service, and there is the internal service, which is called the cluster IP. So the internal service is cluster IP. This is, I will not go into details because there is a mechanism why it is called internal service and why this external service ES is called node port, or node port is called external service. I cannot explain in such a short time. Okay, but you have got the essence that service. You hit the service, service will take you to the pod. That is the flow. That is the workflow. And finally, we come to the last topic, which is, as I told you, it is the ingress controller. A Kubernetes cluster, I do not want to use the elastic load balancer, which is costly, okay, or any load balancer provided by any cloud, because then I'm spending a lot of money for the company. Every hour it will be charged, whether you use it or not, because you have used, whether the electric there is a huge amount of requests coming in and using it, of course you will be charged. Even if there is nothing hitting the elastic load balancer, even that time it will be charged. Because to host that load balancer is one service. This is one service that you have taken it from. So this service has to be made up and running by AWS. So for that running state of that resource, you are getting charged, whether you use it or not. So I will go for ingress controller. An ingress controller has a pod called Nginx. Nginx is the application. So this is a pod within the ingress. So in all, there are lots of types of ingress controller, but Nginx ingress controller is the best one. Best and the most cost effective. No, there's no cost, and most performance oriented, very good ingress controller, best performance. So ingress controller is one part that you have to install, depending on whether you are doing on bare metal. Bare metal means on-premise metal or on cloud. Whether your Kubernetes is on the cloud. So you will it depends on where you want to do. So install that part for either the bare metal or the cloud. The cloud will be AWS or Azure, whatever it is, whatever cloud it is. You will get all ingress controllers for all the clouds. It's cloud agnostic, doesn't matter. So you will install that part. But how do you access as a user? You are the user. You will not directly be allowed because there is a service account. Service account will implement the RBAC service account. Service account is again a Kubernetes object. And since every cluster will have a service account, so this user is authenticated, authorized by the service account that you have created. Now, so this authorized user can hit the ingress service. Now, what is that? Ingress service is either a node port or a load balancer. This load balancer is not the AWS ELB, Elastic Load Balancer. This is a service. This is the external service. You see, you cannot directly. This is the cluster IP. As I told you, this is an internal service. This is an external service. You cannot directly go and access the internal service. Then even if you are a big hacker, so that's why the hackers will also find it very difficult to directly hit one service and go to access one application. If you access one application by directly going this, then your database, your data is exposed. It is not good. You have to be authorized. You are the only authenticated user. So there is a lot of layers for your security. Anyway, you will hit the ingress service, which is node port, which is the external service. This external service is from ingress, from this controller, ingress controller. Whenever you install this ingress controller, it will install or it will implement an ingress service for you. So there is a node port. Let's say the node port ranges between 30,000 to 32676, which is 2 to the power of 16. Whatever the port number, this is a port number. So this when you install the ingress controller, one node port by this between this range will be generated, and in your URL you will specify that node port. That's all. You will hit this ingress service. Ingress service will take you to the ingress controller. Ingress controller will take you to the ingress rule. This is another object that you will create. You will create this ingress object. This is a set of rules, and one of the rules is will take you to this cluster IP service, internal service, cluster IP, you see, internal service. And once you root, and if you, otherwise you will be rejected. You have given the URL as demo.com/video. So this is the endpoint. So it will take you to the video service, not to the image service. This is the image service. This is the video service. So if your endpoint, the URL says that you will hit this node port and to this demo.com/video, that is the endpoint, then it will definitely take you to this service, and this service will give you this video application. If you hit the image, you will hit this service and you will go to that image service. Like this is a Google photo application, Google Photos, you know, Google Photo. And this is your Netflix application. Then Netflix is a set of videos, on-demand videos or whatever. This is the service. So through this service, you are reaching Netflix and you are seeing the whatever the request is that you want to see a current movie which has been deployed over this Kubernetes cluster, and you as a user are now watching a movie. This much all that I can say. There are lots of things in Kubernetes I could not cover because that is out of scope. If you have any questions, please let me know. Otherwise, this is the end of our discussion for today. Okay.
Thank you, Mr. Debashish.
Thank you. Sorry, I could not enable my video, I mean the camera, because I could not, I tried a lot, but I could not make that device connected.
That's fine. I think it's
basically
all good with
mobile
that.
connectivity.
So guys, this is our end of our internship program and of our DevOps. So next weekend, we are going to take 1 week break. And from next weekend, we are going to start our cybersecurity new batch. And we need to find out that when we can start our DevOps new session, the free internship plan. We are going to discuss with Mr. Debashish, and we will let you know very soon. But in our next in DevOps internship, we'll add some more features and to make it more relevant, and we try to add few more things. So here I can see Silasi, Luis, Okilora, you do have my number, so whatever you record, you just ping me. Rest of you guys, if you have any question, doubt, feel free to ask.
Yeah, thank you, Mr. Debashish. You've been very wonderful. I'm just going to encourage those of us that are here, if you have not actually signed up for the DevOps, the premium class, the hands-on, I will advise that you do so. There's a lot to be gained from there, So I've been there. You still see me coming back, still listening to the internship. No knowledge is lost. You just want to be on top of the game. So there's always something new.